Hi there guys, and welcome to this video, and we're going to look at the hardest type of trig equations that is probably slightly above the FSMQ level, the additional GCSE and the first year of A level. So we've got this equation here, and you can see we've got different ratios, so we can't even begin to solve until we've got just a single trig ratio. So we have to think about which one we're going to make it. Are we going to make it cos? Are we going to make it sine? And we've got to solve it for the interval here, minus 180 to 180 inclusive. So when I look at this, I've got sine here, sine there. It makes sense to make them all sine. I can easily change this to sine using one of the identities. That to cos, no, but that to cos, super easy. So let's make them all sine. So this is the same as 2 lots of 1 minus sine squared x plus 9 sine x is equal to 3 sine squared x. So if we expand the bracket, we get 2 minus 2 lots of sine squared x plus 9 sine x equals 3 sine squared x. Okay, so we've got a quadratic. It's a funky looking quadratic, but nonetheless, we're going to get everything on one side, because when we solve quadratics, that is what we do. Now, what's our highest power? The sine squared x. We've got a positive here, we've got a negative here, so let's get everything onto this right hand side. So that means we would have 5 sine squared x minus 9 sine x minus 2. Now normally, in this stage, you would look to factorize. So I like to just go for it. So that's what we're going to do. Now, sine squared x is just sine x times sine x, so I'm going to pop that in there. Now 5 is a prime number, so factorizing is super easy when you've got a prime. So it has to be 5 times 1. And this end number is prime as well, so the only options I have is 1 and 2, or 2 and 1. Now I need to I can see that 5 times 2 is 10, and that's really close. So if I put the 2 there and the 1 there, I get a 10 sine x and a 1 sine x. I can definitely make a minus 9, so it's be minus 10 plus 1. Which leaves me with sine x is equal to minus 1/5, and sine x is equal to 2. Now I can immediately just rule out this one, because the sine ratio will only go up to 1 or minus 1, so that's not going to give me any solutions. But this one will. So we have to draw a cast diagram. We know this sine ratio is going to give us a negative output, so sine is negative here and here. And what are these angles? So time to grab the calculator. Inverse sine of minus 0.2, and just before I hit equals, remember we're going to get a negative answer. I'm just going to ignore that. So it's 11.5 to 1 dp. So 11.5, 11.5. So for minus 180 to 180, so we're going to go round here and here. But if we go in the positive 180, you can see we don't actually get any results. So x is equal to minus 11.5 and minus, what is that? Don't want to get this wrong on a video. Minus 168.5. Okay, so that's the first one you've really seen of this kind, with all the factorizing as well. Let's have a look at some more. Okay, so this is slightly different. So I'm just going to write this out again, because it's not that easy to see. So I've got sine x tan x equals 4. Right, so can I turn a tan x to sine x? Not really that easily. And I can't, well, and vice versa. It's pretty hard. But there's no squared, so the only identity that I'm really going to use here is tan x is equal to sine x over cos x. Okay, so that means I can say sine x times sine x over cos x is equal to 4, which means I have sine squared x over cos x is equal to 4. So I started off with a sine and a tan, and I was thinking, can I make it them? But now I've introduced a cos, you should be able to see that sine squared x I can turn into the cos ratio, and that's the only ratio we'll have left. So using the other ratio, the sine squared x plus cos squared x is identically equal to 1. I can write this, and did you know, I was going to times by that, but I held back. So then we get 1 minus cos squared x is equal to 4 cos x. The highest power is at the moment negative, so let's put everything on this side. So cos squared x plus 4 cos x minus 1. So we're going to try and factorize. We have to use a double bracket factorizing because there's no highest common factor. This should be easy because it's just cos x and cos x. Now this one's not easy because there's no factors of 1 that make 4. So you've got a few options here. You can bung it into the quadratic formula, or should we have a go at completing the square? Why not? That looks fun. So cos x, and we're going to halve the coefficient here, so we've got 2 squared. We're going to take away this value here squared and pop this one on the end. So we end up, I'm going to do something a little bit, skip a little step here, so that'd be minus 5, so we end up with that. So cos x would be plus or minus root 5. So sorry, that's cos x plus 2. Let's make this a bit further down. And we have cos x is minus 2 plus or minus root 5. So we actually have 2 values. Now, root 5 we know is going to be a little bit more than 2, because root 4 is 2. So if we have minus 2 and we take away something else, we're going to get something bigger or lower than minus 1. So we can ignore that one. But if we have minus 2 plus root 5, we get 0.236. So I'm just going to write one value because we can ignore the other one. And that is actually a positive because this is bigger than minus 2. So let's draw a cast diagram. I'm just going to draw it over here. C-A-S-T. The cosine is actually positive, so it's there, and how big are these angles? So inverse cos of that is 76.3. So 76.3 in both of these. Now what's our range? Let's go back up to the top. 0 to 360. So look, it's not allowed to include the 360, so just bear that in mind, but with this type of answer it's not going to make much difference anyway. So we've got 1 here, and we're going to go all the way around to there. So let's just finish this off. So x is equal to 76.3 degrees, and x is equal to 283.7 degrees. It's absolutely fine to round all of these to one decimal place right at the start. Okay, I've got a couple more to show you. So very similar looking one. So you can see we have a quadratic. We've got 2 cosine ratios. So let's make this a cosine. So we end up with 2 cos squared theta minus cos theta minus 1 is equal to 1 minus cos squared theta. Everything on this side this time. So 3 cos squared theta minus cos theta minus 2. Let's go for the factorizing. So 3 cos theta. I meant to say earlier, some people don't like this stage and they say, right, let cos theta be x. So you have 3x squared minus x minus 2. You can do that if you want. I don't think it's necessary. And just looking at this, I can see 3 and 2. I can make this 1 cos theta, so it has to be minus 3 plus 2. So I get cos theta to be minus 2/3 when we solve this, and cos theta to be 1. So now both of these are giving me valid answers. So let's do the one on the left first. Cast diagram. Cosine is negative, so it's negative there and there. Let's work this out. So when we do this, what it's actually going to do is going to give us that angle there. So you're going to get an obtuse angle, but remember we want the acute ones. That's the only thing you need to be careful of with these. So shift cos minus 2/3. So it gives me 131.8, so I'm just going to minus that from 180, and I get 48.2. So here I have, what did I say, 131.8, that was it. And we have another value, just add that onto 180, it's 228.2. Now, for this one, with a 1, when it's ones and zeros, I just go back to the graph. I just think it's so much easier. So here is 1. So when does it equal 1? Well, at 0, so theta is 0, and at 360. Now, this is good because this value here, it says it's not allowed to include 360, so I'm going to get rid of that one now. So I have 3 answers, 1 and 2 and 3. This bit about rounding where appropriate, obviously it isn't there, but it was those two. Right, one more. Okay, I had to make this one up, so I couldn't find a good question on this, but it's ever so slightly different to the others. So we've got a quadratic, so everything needs to be on one side. This is the higher power, so it makes sense to keep everything on here, and it would be positive, so that would be much nicer. Okay, but you can see now we have a common factor to both terms, so we're going to factorize a single bracket this time. So these are technically easier questions, but for some reason people don't spot the easy factorizing, they just always think it's going to be a double bracket. And it technically is, it's just cos theta plus 0. So we know cos theta is going to equal 0 and cos theta is going to equal a half. So again we've got 2. So with zeros and ones we go back to the graph. So when does it equal 0? Here and here, which is 90 and 270. For this one we're going to draw a cast. It's positive here and here. So let's work out what that angle is, and that's 60. So we're going to get it to be 60 and 300 when we go round for this range here. Okay, guys, that's your lot. Lots of different examples. It's time to get practicing, and I wish you the best of luck.